Welcome to A-Level Mathematics. In this lesson, you'll learn exponentials and logarithms step by step, from the basic rules to solving equations and real-world applications.
An exponent, also called an index, tells us how many times a number is multiplied by itself. For example, 2 cubed equals 2 times 2 times 2, which equals 8. The expression a raised to the power n consists of a base and an exponent. The base is the repeated number, while the exponent tells us how many times it is multiplied. The first law of exponents is the multiplication rule. When multiplying powers with the same base, simply add the exponents together. The division rule states that when dividing powers with the same base, subtract the exponents in the denominator from the exponent in the numerator. The power of a power rule tells us to multiply the exponents. 3 squared raised to the 4th power becomes 3 to the 8th power. When a product is raised to a power, apply the exponent to every factor individually before multiplying the results together. A negative exponent means take the reciprocal of the positive power. Any non-zero number raised to the power 0 always equals 1. An exponential function has the variable in the exponent. As the value of x increases, the graph grows rapidly. As x becomes negative, the values get smaller but never reach 0. Notice how exponential functions grow rapidly as x increases. For negative values of x, the graph approaches 0 but never actually touches it. A logarithm answers one important question. To what power must the base be raised to produce a given number? Logarithms are the inverse of exponents.
For example, log base 2 of 8 equals 3, because 2 raised to the 3rd power equals 8.
Similarly, log base 10 of 1000 equals 3, and log base 5 of 125 also equals 3, because each base raised to the 3rd power produces the given value. A common logarithm has a base of 10. When no base is written, base 10 is usually assumed. The natural logarithm uses the special number e, approximately 2.71828. It is written as ln of x and is widely used in science and engineering. You can easily convert between exponential and logarithmic forms. 3 raised to the 4th power, 81, is exactly the same as log base 3 of 81 equals 4. Likewise, 10 to the 5th power equals 100,000, so the common logarithm of 100,000 equals 5. Just like exponents, logarithms have important rules. The 3 most useful are the product rule, quotient rule, and power rule. The product rule states that the logarithm of a product equals the sum of the logarithms of its factors. This rule makes large calculations much easier to simplify.
The quotient rule states that the logarithm of a quotient equals the logarithm of the numerator minus the logarithm of the denominator.
The power rule moves the exponent to the front of the logarithm. This makes expressions much easier to simplify. To solve exponential equations, first express both sides using the same base whenever possible. Since the bases are identical, simply equate the exponents. Therefore, x equals 5. For this equation, rewrite 81 as 3 to the 4th power. Then compare the exponents to find that x equals 3. To solve logarithmic equations, rewrite them in exponential form. Log x equals 2 means 10 squared equals x, so x equals 100. Likewise, log base 2 of x equals 6 means 2 raised to the 6th power equals x. Therefore, x equals 64. Sometimes your calculator doesn't support a particular logarithm base. In that case, use the change of base formula.
For example, log base 2 of 20 equals the common logarithm of 20 divided by the common logarithm of 2, giving approximately 4.32322.
You've now learned the laws of logarithms, how to solve exponential and logarithmic equations, and how to use the change of base formula with confidence. Let's apply the laws of exponents. Add 5 and 3 to get 8, then subtract 4. Therefore, the simplified answer is 2 to the fourth power, or 16. For logarithms, use the product rule. Log 50 plus log 2 becomes log of 50 times 2, which is log 100, giving an answer of 2. Consider 5 to the power 2x equals 125. Since 125 is 5 cubed, 2x equals 3. Therefore, x equals 3 over 2. Exponentials are useful for modeling continuous growth model is p equals p0 e to the power, where r represents the growth rate and t represents time. Exponentials also model compound interest. The formula a equals p times 1 plus r over n raised to nt describes how an investment grows when interest is compounded. Exponential functions can also describe radioactive decay. The model n equals n0 e to the negative kt shows how the quantity decreases over time. Remember, logarithms are the inverse of exponentials. Master the rules, solve with confidence, and apply them to the real world. Thanks for learning with UNIC EDU.